Bismillah ar-Rahman ar-Rahim. Assalamu alaikum, dear students. This is your weekend homework assignment for AS Physics, and I thought it better to make a video solution for this so that if anyone from you is facing some difficulty in understanding or solving some question, then he or she can immediately take help from this video, and you can check your answers as well, and you can learn some new ways to solve some trickier questions as well. So I'll try to finish up with this video within 20 minutes. So it's a suggestion for all of you to watch this video very carefully, especially if you are finding it harder to solve some of the questions. Okay, so let's start the beginning. First of all, let's start with this question number one. Well, in the statement, there is an equation which is given right over there. And then, of course, all the quantities are explained. Let's say E is the thermal energy, and then A is the cross-sectional area, and then T1 and T2 are the temperatures, of course, with the Kelvin unit, L is the length, and C is the constant. And they said that you have to find the SI unit for C. So first of all, this is case 2 or type 2 question in which you have to find the unit of some quantity. So first of all, what you have to do is you have to make C as the subject. So make C as the subject. So it is E into L by A T1 minus T2 into small t. Okay, so now what you will be doing is you have to put the units for these quantities. E is the energy, and you know energy's unit is kilogram meter square per second square. This is the most common thing. Energy is equal to work done, which is equal to F into D. And you know F is MA, MAD. And when you plug in all the units for this, it will be kilogram M2 S minus 2. Okay, then what is L? L is the length of the rod, so it is in meters. A is area, which is meter square, and T1 minus T2. So T1 minus T2 is actually change in temperature. T1 minus T2 is change in temperature. And you know that change in temperature's unit is Kelvin, so it is Kelvin. Right? No, not over there, but we have to write it here, Kelvin. And then what is small t? Small t is the time. It is the time. So it's second. So now what you'll do is you'll do some cancellations. This meter square is gone with this meter square, and this 1 second is gone with this power. So it is, we are left with kilogram, meter, second, and K minus 1. So that is the unit. Kilogram, meter, second, K minus 1. That is the SI base unit for C. Okay, let's move on to question 2 now. Question 2, you have to tell that which quantity is having the reasonable magnitude and the stated unit. So mass of an apple, mass of a coin, sorry, mass of the coin is 10 power negative 4. Well, 10 power negative 4, you know, is equivalent to 10 raised power minus 1 into 10 raised power minus 3 kilograms. So kilo is, you know, 3. Or you can do it in another way. This is like a complicated way. So it's like 0.0001 kilogram. And then, of course, it is 1, 2, 3, 0.1 gram. That is equal to 0.1 gram. So it means mass of a coin is 0.1 gram. No, it must be greater than that. Then thickness of the sheet of paper is 10 power negative 2 meter. So 10 power negative 2 meter is, you know, it is equal to 1 centimeter, because 10 power negative 2 is equal to centi. So 1 centimeter, well, it's too much thickness for a paper, right? So that's incorrect. Then weight of an apple. Weight of an apple is 10 power 0 Newton. 10 power 0 Newton, you know 10 power 0 is 1. So 1 Newton, 1 divided by 10, because G's value is 10, is about 0.1 kilogram. And 0.1 kilogram is about 100 gram. So yeah, we have learned that mass of an apple starts from like 100 grams. So yeah, that seemed to be correct. Its unit is also correct. Then temperature of a person's body 10 per 1 Kelvin. So 10 per 1 Kelvin, like 10 Kelvin, no, because the human body temperature is around 37 degrees Celsius. And when you convert into Kelvin, you have to add 273. So it's like almost 310 Kelvin. So yeah, this is incorrect. So your correct option is option C, which is weight of an apple. Next thing, question number 3, what is the unit of resistance when expressed in SI base units? SI base units mean kilogram, meter, second, ampere, and Kelvin. Okay, now let's try to solve it. So resistance is V over I. This is the definition. And then V is work done per unit charge, right? V is potential difference, work done per unit charge. Work done is force into distance. And then this Q comes down. So F is MA into D, I is I, and Q is IT, because charge is equal to IT. Now what you have to do is you have to plug in all the SI base units. So for mass, it is kilogram. For acceleration, it is meter per second square. For distance, it is meter. For current, it is ampere. For current, it is ampere. For time, it is second. So now simplify it. So kilogram, meter square, and this S and this S, this will be S minus 3. And these two A will be moving up, so A minus 2. So this is A plus 2. This is not true, not true. So out of these two, it's the last option that is correct. Okay, question number 4. A byte comprises of 8 bits. How many bytes are there in 1 terabyte? Okay, that's the simplest question. Tera is 1 into 10 to the power 12 byte. But as in 1 byte, there are 8 bits. So how many bits are there? So you'll just multiply this with 8. So this is 8 into 10 to the power 12 bits. 8 into 10 to the power 12. So option D. What is the reasonable estimate for density of sand? Density of sand. Okay, sand is solid, and we know the density of water. So density of water is 1 gram per cm cube, or it is 1000 kilogram per cm cube, per meter cube. So as sand is denser than water, right? So sand density is of course higher than water density. So what you do is in the first A, the answer is 200 gram per cm cube. For water, it is 1 gram, and for sand, it is 200 gram. That's too much. So this cannot be the answer. Then the next is 2 into 10 to the power 3, which is like 2000 gram per cm cube. Again, when you compare it with water, water is 1 gram per cm cube. So that is too much. So no, that's not the option. Then number 3 is 20 kilogram per meter cube. Now compare it with the water. Water is 1000, and how sand can be 20 gram? Because sand is having density more than water. So this is not true. So the only option left is D, which is 2000 kilogram per meter cube. So that seemed to be correct. Why? Because water density is 1000 kilogram per meter cube and sand is 2000. So yes, sand must be heavier than the water. So that's why the option is correct. Okay, which physical quantity have the unit of Newton second square per meter? So Newton, and then second square per meter, you take it at denominator, you shift it to denominator. So the power changes, meter changes to meter, m minus 1 changes to m, and s2 changes to s minus 2. So Newton is the unit of force, and ms minus 2 is the unit of acceleration. So force over acceleration is equal to mass. So it means it is equal to mass. Then what could not be the measurement of a physical quantity? For measurement of a physical quantity, a value plus unit is required. So in the option A, it is 10K. K is not the unit, so this is your answer, because over here 11 is the value, this is the unit, 17 the value, this is the unit, 25 is the value, T is the prefix, and M is the unit. So all other are correct, and he was saying not true. So A option is not true because there is no unit in that. So that means it's not the physical quantity. Moving on to the next one, 128 GB. So you have to express it in standard form. So 128 into 10 per 9 byte, and then decimal is here. So you have to shift it to first non-zero. So it is 10 power 2 because you have shifted 2 places. So then you add them. So it is 1.28 into 10 power 11 bytes. So 11. So B is your correct option. Moving on to next one. FV is KRV, where FV is the drag force. K is the constant, and this value is given. Then R is the radius, and V is the velocity. So they're saying you have to find SI base unit for K. So make K as the subject. So it is F over RV, force is MA, and then simply put the SI base units. Mass is kilogram, acceleration is meter per second square, radius is meter, velocity is meter per second. Put the units. And then you have to simplify them, meter, gone, and you're left with kilogram, M minus 1, S minus 1, because when you take this upstairs, so S minus 2 plus 1, that will be S minus 1. And this M, of course, when you take it upstairs, it will be M minus 1. So it is kilogram, M minus 1, S minus 1. Okay. What is the alternate way of expressing energy of 43 decijoule? 43 deci. And look here, it's in milli, mega, and mega. So this question we have studied in prefixes when you have to convert one type of prefix into another. So first you remove the prefix of deci, its value, and then try to convert it in milli, because milli seems to be closer to deci, because deci and milli both are very close to each other. So milli, is 10 to the power minus 3. So 10 to the power, try to make it minus 3. So you have to add plus 2 over there. Why? Because it was originally 10 to the power minus 1. You make it minus 3. So you have added extra minus 2 over there. So at this place, you'll be writing milli, and then you'll be solving these two. 43 into 10 to the power 2 is 43. 100, of course, into 10 to the power 3 place is millijoule. So then you shift it 1, 2, 3, 4.3 into 10 power 3 millijoule. So the option A seems to be correct. Okay, let's move to next. The mobility mu of the electron traveling through the metal rod is given. Okay, this is the equation for the mobility mu. E is the charge on the electron, M is the mass. The average time between the collision of electron and atom is T. T is the time. Like E is the charge on electron, M is the mass, and T is the time. What is SI unit of mobility? U. So it's quite simple. Just plug in all the SI base units. The charge unit, charge. For charge, it is IT. Q is, charge Q is equal to IT. So you have to put IT and M and then this T. So ampere for current, time second, this time again second, and then mass is kilogram, right? So its unit is AS square per kilogram. So AS square per kilogram. Yeah. So B is the option. Okay, number 12. Number 12 is again the same thing. An equation is given, and what you have to do is you have to find SI base unit for L, and every other thing is given. R is the radius, T is the temperature, alpha is the constant with a given unit. Like these are the given units for the alpha. So just that 4 pi has got no unit, so cancel that. R is radius, so it is meter square. Alpha unit is given, which is watt per meter square per K minus 4, and T4 is Kelvin 4, right? So this Kelvin 4 and Kelvin 4 goes away, cancelled away. So you're left with, and then again, this meter square and this meter square cancelled away. Kelvin 4 cancelled away. You're just left with watt. And watt is like unit of power, and power is energy over time, which is joule per second. And joule is kilogram meter square per second square over second. So that is kilogram M2S minus 3. Kilogram M2S minus 3. So like you just have to convert, because watt was left over there. Now, so you have to convert watt. Watt is Power is energy over time. Unit of power is watt. Unit of energy is joule. Unit of time is second. So that's how I have written at place of watt, joule per second. And then, joule is the unit of energy, which is kg meter to s minus 2. So that's how you solve it. Okay. What is the reasonable estimate of kinetic energy of car traveling at 30 meter per second? It is half mv square. And mass of car is approximately, let's say 1200. Speed is 30 square. So this is like 600. So 600 into 900, it is around 54, like this. So 1, 2, 3, 4, 5. And then it is, and 6. So it is 0.5 into 10 power 6, and 0.5 can be rounded off to 1. So it is 1 into 10 power 6 joule, which is this, 10 power 6. What is the reasonable estimate of mass of a raindrop? This is interesting. Raindrop. Raindrop is like a simple drop of water. It cannot be 10 kilogram. It cannot be 0.1 kilogram. That is too much. 10 to the power minus 3. It is like 0.001 kilogram, or it is 1 gram. 1 gram. So is it possible that mass of raindrop will be 1 gram? No, it is not possible. So the only option left is 10 to the power minus 5, which is in like milligram. Okay, a sample of gas has a density of 4.8 microgram and its volume is 1.2 decimeter cube. What is the density of the sample? And all the units are in SI unit. So what you have to do is, that density is mass over volume. So mass is 4.8 micro. So convert micro, which is minus 6, and then you have to convert that into kilogram. So for kilogram conversion, you'll multiply it with 10 to the power minus 3 because you have to use mass in kilogram. And then divided by your volume, and volume is like 1.2 dm cube. I told you other day that dm cube actually means dm cube. So it actually means deci cube meter cube. So over here, deci is 10 to the power minus 1 cube. So that's how you convert the units into SI units. So then you have to simplify. So let me simplify it for you. 4.8, first simplify this. 4.8, 1.2. So it is like 4. This would cancel away with 4. And then 10 power 6, 10 power minus 3 is 10 power minus 9, and then minus 3 going up. So it is plus 3. So you can say that it is equivalent to 4 into 10 power minus 6 kilogram per meter cube. So 4 into 10 to the power minus 6. That's your answer. A man is running in a race in a straight line. What is the approximate value of kinetic energy? Well, the kinetic energy of the man. Okay. So half mv square. The mass of the man is approximately like, you can take 80 kg. And then he is running in a straight line. So what should be his speed? Like I told you the other day, the runners have in 100 meter have a speed of 8 meter per second to 12 meter per second. But of course, if a man is running, it means you can take maybe 5 meter per second. Yeah, because he's not the athlete, he's the man, ordinary man. So this is like 40 into 25. So 40 into 25 is approximately how much? 1000. Yeah. So our answer is exact 1000. Otherwise, it's estimate. So answer can be like 900 or other. Okay. So let's go to this one. Energy E is stored. Q is the charge. C is a constant. You have to tell what is the unit of constant C. Again, that's quite simple. You have to make C as the subject. So it is Q square over 2E. And Q is the charge, which is IT. So IT square over 2E. And E is the energy. So it is like ampere second square. And then 2 has got no unit. Energy is kilogram meter square per second square. So this will be like A square S square over kilogram M2 S minus 2. Simplify it. So kg minus 1, you're taking it upstairs. M minus 2, taking it upstairs. And then S4, you're taking upstairs, and A2. So that will be the unit. Kilogram meter minus 2, S4, and A2. So this is the unit. What is the unit of momentum? Well, quite simple. Momentum is mv, or momentum is force into time. So force is Newton, time is second. So it is Newton second. Yeah, it is second. Or otherwise it can be kilogram meter per second, but meter per second is not there, so Newton second. Which term represent a physical quantity? Meter? No, it is the unit. Percentage uncertainty? No. Quark flavor? No. Spring constant? Yes, because spring constant is K, which is equal to F over E, and its unit is Newton per meter. So yeah, this is the quantity. Okay, which two units are identical when expressed in terms of SI base unit? So which two are identical? Okay, let's see. Joule per coulomb. Joule per coulomb. So joule is kilogram meter 2s minus 2 because this is the unit of energy. Coulomb is like ampere second. So you convert that kilogram m2s minus 3 and a minus 1. So kilogram m2 s minus 3. We got s minus 3. Yeah, so this is not the option. And because this is s minus 2 over there, so we have s minus 3. So A is not the option. Joule second. Second is joule second. So joule is kilogram meter square per second square into second. So this is kilogram meter 2s minus 1. So kilogram meter 2s minus 1, yes. So B is our option because both have same SI base unit. Okay, which estimate is reasonable? Okay, let's see. Mass of a grain of the sand, 1 into 10 to the power minus 3 kilogram. So 1 into 10 to the power minus 3 kilo. You know, kilo is 10 power plus 3. So this is cancelled away. It means 1 gram. So is mass of grain of sand is 1 gram? No, sand grain is very tiny little thing. So 1 gram is not the mass. Okay, then next, volume of the tennis ball. So we have done that in the class as well. 4 by 3 pi r cube and 4 by 3 pi, and then r is like about 0.03 cube. So we have to do some calculation. So let me do that for you. 4 divided by 3 multiplied by 3.142 multiplied by 0.03. So that comes out to be 1, 2, 3, 4. 1 into 10 power minus 4 meter cube. But that is 10 power minus 2. So that is certainly not correct. Then 1 into 10 power 0. 10 power 0 is like 1. So it means 1 joule of work done in lifting an apple from waist height to head height. So waist height to head height is approximately 1. And then, you know, apple mass is about 100 grams. So work done is force into distance, and force is MA. So the mass is about 100 gram, which is in kilogram divided by 1000. Acceleration is 10 and height is 1. So it is 0.1 into 10 into 1, which is 1 joule. So exactly we have this answer, 1. And then 10 power 4 watt for the power of a light bulb in house. 10 power 4 means 10,000 watts. So no, we have never used 10,000 watt at the house. So it means C is your option. Okay, question number 22. An electromagnetic wave has a wavelength of 85 micrometer, and you have to express in meter. That's quite simple. Micro is 10 power minus 6, but in standard form, the decimal point should be after first non-zero. So it is 8.5 into 10 to the power minus 5. So 8.5 into 10 to the power minus 5. Then you have to calculate the frequency in terahertz. So you know V is F lambda, and then frequency is V by lambda. And as it is electromagnetic wave, so the speed is 3 into 10 to the power 8. This is the estimation we have to use. And for wavelength, it is 8.5 into 10 to the power minus 5. So you do the maths. It's 3 divided by 8.5. So it is 0.35. 0.35 into 10 power 13, because this 5 will be coming up. And then you'll round it off, or you will rearrange 3.5 into 10 to the power. Oh, you have to write in terahertz. So yeah, it is 3.5 into 10 power 12. So 10 to the power 12 is tera. So that's why it is 3.5 terahertz is the answer, because 10 to the power 12 is equal to tera. State the name of the region of electromagnetic spectrum that contains this wave. So this is from the estimation. So which wave is having the frequency of 10 to the power 12 hertz? Like that comes in X-ray range. So this is X-ray. Okay, then you have to write the symbols and equation for the following. So we have done that in the quantity chart. So you will, I'm referring you to the quantity chart. So you can check it, your answer from there for these. This is just the knowledge-based stuff. So I hope that things are clear to you. In case you find anything difficult, you can ask me in the WhatsApp group or in the message chat here. Thank you.